Hello and welcome to PropStats. This is Chapter 2, Section 1. We're working on data and graphs. In this chapter, you will need your calculator, and we will do the calculation by R by hand. We will also use StatDisk, so make sure you have StatDisk up and ready to go on your computer. All right, let's go. All right, if you have not, stop and take the online survey for Chapter 2. I do realize that I put questions 1, 2, and 3 in here, and we'll talk about which questions we want to use later. So when you click on this, hopefully, never mind. Go to your Triola survey and you take your Chapter 2. I don't know what that should be going. Oh, there it goes. You should be able to get through it by using your Schoology website. So I would like you to have clicked on that and taken that survey. Now we're going to talk about what we're doing today. And today we're going to be using a frequency distribution. And we're going to create that in this. So this is a lot of graphs today. A histogram and relative histograms and identifying different distributions from those. A frequency distribution just shows how data are partitioned among several categories. So when we're doing this, okay, it stopped working. Here we go. All right, I think we're better. Okay, partition among several categories or classes, and we're going to do the number of frequency and number of items that are actually in those different classes. Now you have to remember that statisticians are generally a little bit lazy, or not lazy, they like things easy. So a lot of things they like to be able to do in their head. So we will put class widths and starting points depending on what's easiest to add. And that can be different for all of you. So some of you may have different values than others, and that's okay. It all depends on how you want to do it. All right, some definitions we're going to talk about are the lower class limit. So that's where they start. So like your partitions start here. The upper class limit is where they end. Class boundaries, it's what's used to separate these. So that's the middle of these two, especially if we're going by whole numbers. All right, so it's the middle of the gap is what we're talking about here. The class midpoint is actually just the middle of the class itself. So we're taking the lower and the upper limits from above and dividing it by 2. It's just finding a midpoint. Class width is actually how long or wide are they. Okay, a relative distribution is the relative frequency divided by the total number of data items that actually happen. And we'll talk about those and create that. It's a little bit different than just a straight frequency distribution. It changes the relative part into basically a percentage is what we're going to be graphing. Cumulative takes a frequency distribution and it adds it up all the way through. So the last number is always your total. And you'll graph all 3 of those. Now let's go through an example. Here is a McDonald's drive-through. So the first thing you need to do, it actually helps to put them in order, but we will not do that this time, is find the number of data values that exist in the set. Well, we got 17 per row. So there's 17 in this one, 17 in this one, and 16 in this one, or 17 times 3 minus 1. I don't care how you do it. You should figure out that you have 50. This is very jumpy today. 50 data items. All right, now we have to divide this into sets, like how many classes. The more classes you have, the wider your data will look like it is spread out. All right, sometimes that's good, sometimes that's bad. Usually look at the number of classes to break up the data, deciding by how many actual data items we have. All right, if we have 50 and we divide it by 5, that means there'll be 10, roughly, like we're looking at 10 per set. It will not turn out that way, but that's kind of what it would divide up to, which is not a bad option. All right, if you chose 6 or 7 or 8, that's even fine too. You don't want to choose too large, because if you choose a number that's large, let's say 20, you're only going to do 2 per set on average, which means you'll have a lot of sets that are empty, and that is something we do not want. So we're going to choose 5 here because 50 technically isn't a lot of data. All right, so the number of classes we're going to have is 5. All right, The class width, then, we're going to take our max value minus our min value. So we go up here to our data and we find our largest number, and then we find our smallest number. Well, if you look here, 308 is the largest number, and our smallest number happens to be on the same line. It is 83. So you found your largest and your smallest. So you take 308 minus 83, and we're going to divide that by 5. This is something we chose. You could have chosen anything different. Okay, when you did that, we get a value of 45. All right, that is actually not a bad value. It does not matter, but it's hard to add in your head constantly. So we're going to round this to 50, just because it is not necessarily mandatory. But when you do this, like, you always want to be able to make it easy to follow for anybody who's reading, and going up by 50 is easy to follow. All right, now choose the value of the first lower class. Well, we know that our smallest number is 83. All right, by using 83 though, 83 plus 50 is not easy and not easy to follow. So if we're going with 50, it's easy to go either by 50s or 25s. Well, if we look at this and you have to go lower because you have to include it. I could go to 50, but that's 30 away. If I go to 75, that's much closer and an easy number to follow. So we're going to let our lower limit be 75. This is something we chose. All right. So now we're going to take and find all of our lower limits. So we do that by adding 50 to each time. So 75 is our first lower limit. Add 50, so this is 1, and we get 125. That's our second lower limit. Take 125 plus 50 and we get 175. That's our third lower limit. Find the fourth and the fifth. So pause and do that. So you should have taken 175 plus 50 and gotten 225. And then you should have taken 225 plus 50, and you should have gotten 275. All of that can be done without a calculator, and that's partially why we like it. We stop there because that gives us our fifth limit, and we know we have 5 data sets because that's what are 5 classes because that's what we chose. All right, now to calculate the upper class limit, you subtract 1. So I'm going to take 125 minus 1, and that gives me 124. Then I'm going to take 175 minus 1. That's 174. So I'm getting where my values are between. So the next one, find the next ones, please. You'll take 225 minus 1 to get 224. Then you'll take 275 minus 1, and you got 274. The problem is here is we don't have the upper limit for this guy. So we have to go one more above that. And to go one more above that, I'm going to take what would have been there, or you can actually just add 50 to this guy. You can take 274 plus 50 to get your 324, or you could have said my next limit would have been 325. I have to subtract 1, which gives me 324. Either way, but you have to get that upper limit. So we got to include all those upper values. Now, what we have come up with is our classes. So that was what goes in here. My first class goes from 75 to 124. My second class goes from 125 to 174. My third class, so here are your lower limits, 175, 225, and 275. All right, lower limits follow the same thing. So now we have the 224. Oh, that went away. And the 274 and the 324. Those are my class limits. Your next job is to go up to your McDonald's value and actually put in the tallies. So we go up here and you're tallying as you go. And we have 107, 139, 197. So we go 107 goes into which group? Well, 107's here. There's my first tally. All right. And then you look at 139. Well, 139 falls here, and you cross him off. 197. 197 falls here, and you cross that off. Okay, pause and do your tally mark, please, and add them up. Okay, hopefully you match mine. In my first one, from 75 to 124, I had 11. The next group I had 24 times. The next one 10, 3, and 2. So we will use those numbers to create a frequency chart. Our relative frequency is just taking those values and dividing it by our total. We know we have 50 total, so we take 11 divided by 50 to get 22%. The next one then, you would take 24 divided by 50, and you should have gotten 48%, or what it would get. Okay, pause and do yours. So now you had 10 divided by 50, which is 20%. You had 3 divided by 50, which is 6%. And then you had 2 divided by 50, which was 4%. Okay, we will use those numbers to create a relative frequency. Your cumulative frequency is adding them up. So my first time I had 11, so I have 11. So to get to 35, that's 11 plus 24. That equals your 35. Then your next one, you're going to take your 35 you had, and we have 10 in the next set. That gives you your 45. Okay, continue. 45 plus 3 should have given you 48. And then 48 plus 2 would have given you 50. This last number has to be the total number of values. Whoops, data values that you have. Okay, I hope you did well. We will also use that create a thing. Class boundaries. Now, if you remember from your definition, the boundaries is the midpoint between the things. So what's in between the data? Well, if we look, we know that we go between, our first one ends at 124. So this is where it ends, and this is where the second one starts. So to find the boundary, we add them and divide by 2, and we get 124.5. And we do the same for all three. So then we add the next two and get 174.5, and I'm hoping that you can see the pattern. So now you've got 124.5, 174.5, 224.5, 274.5, and then we have to continue on the upper boundary and the lower boundary. So to get that, I'm going to add 50 here because they're 50 apart. And to get this lower one, I'm going to subtract 50. So you're just following your pattern all the way through. Midpoints. So now this is the actual class itself. So we know it starts here and it ends here. So the midpoint is you add and divide by 2. So the middle of the first class is 99.5. The middle of the second class is 149.5. Pause and do yours. We are going to use that to create another graph. So that will also become a graph that we're going to use based off the histogram actually. All right, now it should be question 1. We should be talking about the money right here of the survey and create a frequency distribution, a relative frequency, and a cumulative frequency. All right, so you're going to use your data to do that. I don't have that right now, so you're going to have to do it on your own. Okay, the class width, we only have 60 people. So I would still, again, divide by 5 to make sure you do that right to get your number of classes. So, oh, I shouldn't have put the 5 there. So get your upper and your lower bounds. And then I would take those and I would create 5 classes. Use those to create your width, your boundary, and your midpoint. And then we're going to graph these 3. All right, I hope you did well on that. Okay, a histogram is a graph. It's a bar graph. All right, drawn adjacent to each other, so it uses the class boundaries to graph. So we need boundaries of this one. Okay, the horizontal scale represents the quantitative data, so what you actually graphed, and the vertical scale is how many you have. So let's go down here. So 75 to 124. But if I go 75 to 124, they are not matching. So we know we have to go to 124.5 and 74.5. Remember the upper and lower boundary. All right, the boundary here again would have been 124.5, 174.5. Boundary here, 174.5 to 24.5. So that's where all of these numbers came from. Then we just graph our frequency. So in our first class, we had 11. So we go up to 11 and draw it in. Second class, we had 24. Third class, we had 10. Then we had 3, and then we had 2. So that is a graph or a histogram of our data. A relative histogram does the exact same thing. You still have here, but now instead of how many you have, it's the percentages you have. So if you looked at the first one, and it should look almost identical to the first, there shouldn't be much different other than your labels over here. Because when you go here, this was 22%. So this is going by 10%, 20%, 30%, 40%, and 50%. It's the percentage of your data that falls there. So you look, this would have been 48%. It looks identical in shape, which is what we want. 20%, 6%, and 4% is what that's doing for you. Okay, so now you've created a relative frequency histogram. So we went from a frequency histogram to a relative frequency histogram. So the next one is our, here we go. Oh, we got to analyze the data, my fault. Okay, now when we look at this is our frequency histogram. We look for the center of the data. So where do you think the very middle of my data would be? Well, since 48% of it fell here, and we're looking down, we need to find the middle of 50, which is 25. So 25 of my data are going to fall roughly in here, right? Because there was 11 of them here, and there was 24 here. I need to know where the 25th one fell, so it's going to be in the middle of this guy somewhere. Agreed? Because 11 plus 14 is what's going to give me 25 data sets. So it's in the middle of this set someplace. We don't know where, but it's in here. Okay? I want to look at the variation. So how does it change? I want to look at the distribution. What does it look like? Are there any outliers? And is there any time involved? Well, if you look at our data, it's roughly around 160 to 170 seconds. Because when you look here, my data is going to fall here. The 25th is going to be in this area somewhere, which is probably 160 to 170 seconds. This is an educated guess. We should all be in a general range. If you said 165 to 175, or 170, I don't know if I could really count you wrong. It would be somewhere in this area. So we're including that middle value. The variation of data varies from 75 to 325 seconds. This is how my data varies generally, because we started at 75 and we went to 325. So that's a variation in my data. If I look at it, it's a very rough bell shape, all right? But there's more data on this place. So if I look at the middle here, all right, where the 25th data would show, this looks like it's shaped this direction. So from here over, I have got a lot of data in here and not as much here. So it's either bell-shaped, or you could say it's skewed right, because my data is falling to the right of my middle. Skewed right. Okay, outliers. An outlier, there are none. What that would look like is that it would be blank and blank. There would be no data here. And then all of a sudden, I would have a data value. If I have a data value that's separated by a lot of blanks, this would be our outlier. And we have none. They're all touching. Even if it's only separated by one, that's not necessarily an outlier. But when you have a large set of blank data, that's when you get an outlier. Okay, time. This doesn't have any effect because this is all lunch time. All right, there is none of this that was taken at breakfast and then at supper. It was all taken at one step. So time has no relevance in our data. All right, I want you to create a histogram for our data from the first survey or the one with the money. So I actually want you to draw it out. Make sure you are paying attention to your boundaries. That's what you're looking at here. And then where they fall. It will look very similar to your histogram. All right, let's look at distributions. This is what things could look like. So this one here is a beautiful bell shape, all right? It's very, very symmetrical. Like when we look roughly where the middle is, we have the same amount of data here as we do here in the same area. It's pretty. A uniform means everybody has the same amount all the way across. These are almost identical. That's called a uniform distribution. All right, these next two are skewed data. Now, when you look at skewed data, you look at your top. All right, now, when you look at this, my data seems to pull out more on the right. So that is a right skewed. If I look here at my top, my data is skewed to the left because it's pulled out over the left. There's a lot of variation on that side. All right, I know this sounds ridiculous, but when you think of your feet, all right, if it looks like the toes on your foot, that is the direction it is skewed. So like here's your big toe, and here's all your little toes, right? Okay, that is on your right foot. So it's right skewed. Here's your big toe. Here's all your little toes, all right? So this would be your left foot, so it is left skewed. Might help you remember. I know it's ridiculous, but it works for me. All right, check out your data. Which direction is it skewed? All right, next is normality. Remember those scatter plots and those reference lines? Okay, we will actually be creating that line by hand. We will also use data for it. Okay, normal means I can draw a straight line. These data, the data not on the line are the same above as below. They look pretty good. There's no other wave or pattern being shown. That's a normal distribution, right? Go here. This is not a normal distribution. If you look, it looks like the majority of your data is at 0. So since I have all this data here and the rest is here, it is not a normal skewed distribution. Now this guy's tricky. If you look the same number above as below, it follows pretty much a straight line, but when you look at your data, you can see the wave, right? So some of those that are in class, see that sine wave right there? Okay, if it's following a wave, it is not a normal distribution, even though it has a high R. So you always have to look at your data on a graph and create it that way. Okay, I hope that helps. Good luck, let's do well, and get your homework done.